Hi, Chem students, and welcome to today's lesson over ions and the formation of ionic compounds. Please have out your notes and something to write with. Now that we've learned a little about valence electrons, we can talk about ions. An ion is a charged particle that forms when an atom loses or gains electrons. Atoms lose or gain electrons in order to bond with other atoms and become more stable. Remember that atoms are neutral because the number of protons equal the number of electrons. But what if they're not equal? That's when you have an ion. When an atom loses electrons, this results in a positively charged ion called a cation. I think it's helpful to circle the T because the T kind of looks like a plus sign to remember that cations are positive. When an atom gains electrons, this results in a negatively charged ion called an anion. Sodium atoms have 11 protons and 11 electrons. If a sodium atom loses 1 electron, its charge will be +1 because it then has 11 protons but only 10 electrons. So if it has 11 positive charges and 10 negative charges, the overall charge is +1. That is why it becomes an ion with a +1 charge. And you would write it sodium Na with a plus sign. So here are some examples of different elements and ions. So sodium, the ion that will be formed is sodium +1. So if it's positive, this means that it has lost 1 electron. Chlorine becomes -1, meaning it has gained 1 electron. Magnesium, +2, so it's lost 2 electrons. Nitrogen, -3, so it has gained 3 electrons. Go ahead and pause the video and try to do the last two on your own. All right, welcome back. I hope you got oxygen and aluminum correct. If oxygen's -2, that means it's gained 2 electrons. If aluminum is +3, that means it's lost 3 electrons. One way that I think is really helpful is to remember that electrons are negatively charged. So if you've gained a negative charge, you've become more negative. If you've lost a negative charge, it's like subtracting a negative number, which ends up in a positive overall charge. Okay, a pattern exists with the representative elements. Write this on your periodic table. So this first little group here has a +1 charge. This next group, +2. We're going to go ahead and skip the transition metals because they have variable charges. We'll talk about this later. Boron, that whole group is +3. Carbon is strange, just like the transition metals. That whole group has variable charges. Then the nitrogen group, -3. Oxygen group, -2. And fluorine group, -1. Group 18 elements are our noble gases. For our purposes, they do not form ions, so they have 0 charge. For groups 3 through 12 and 14, ion charges can vary within the group and even vary for one metal. Example, sometimes copper is +1 and sometimes it's +2. So we cannot assign a charge for these groups as we did above. We will go into more detail on this later. However, this is really important. There are some I need you to memorize. I need you to memorize the charges for these 3 ions. So for silver, it's +1. Zinc and cadmium are +2. So they're right here on your periodic table. The +2s are on top of each other, and then the +1 silver to the left. So those 3 metals, even though they're in the transition metal section, they do have these definite charges, and they do have to be memorized. One thing I want to point out that the formulas and charges for polyatomic ions can be found on the back of your periodic table. Those do not have to be memorized. For example, acetate has a -1 charge. Ammonium is a +1 charge. It's the only polyatomic ion with a positive charge. Carbonate, +2. Chlorate, -1. Chlorite, -1, etc. So the top number is the charge on the polyatomic ion. Okay, so ions and electron configurations. So electron configurations for ions must be adjusted based on the number of valence electrons lost or gained to form the ion. So remember, ions are not neutral. Their protons and their electrons are not equal. Because they've either given away electrons or they've gained electrons to become stable, they are charged. So this impacts the electron configuration, and we'll talk about that in a minute. So calcium, it's a metal. Its electron dot structure would have 2 dots because it has 2 valence electrons. It's going to lose its electrons in order to form Ca2+. All right. Oxygen, on the other hand, is a nonmetal. So what nonmetals will do is they will gain electrons in order to form 8 electrons total. So if we look at oxygen, it is 1, 2, 3, 4, 5, 6, 7. It's going to have 6 valence electrons, so it's going to have 6 dots. It's going to gain 2 electrons in order to have 8. Now, when it gains those 2 electrons, oxygen becomes negatively 2 charged. So it's important that you understand that. If you're gaining 2 electrons, you are gaining 2 negative charges. So therefore, you become negatively charged. I'll do aluminum, and the others you should be able to do on your own. So aluminum is a metal. It's located right here. It has 3 valence electrons, so we'll put 3 dots around it. Aluminum, because it's a metal, is going to lose its electrons. It's going to lose those 3 electrons, and by losing those 3 electrons, it becomes Al plus 3. Okay, try fluorine, potassium, and nitrogen on your own and check them with the key online. Now for each of the above elements, write the electron configuration for the atom and then adjust the configuration for the ion by losing or gaining the proper number of valence electrons. So if you look, I've written out these configurations for you. And all we have to do now is adjust them based on whether they've lost or gained. So oxygen, we just said that it is going to gain 2. So it's going to be negatively 2 charged. Well, if this is a neutral oxygen, it needs to gain 2. So it will be 1s2, 2s2, 2p6. You can also check because in this outer energy level, now it has 8 valence electrons, which is very good. Okay, aluminum. We said aluminum is Al plus 3. This means it's going to lose 3 electrons. So if we look at aluminum as a neutral atom, in the outer energy level, it's going to lose 3 electrons. So it will also be 1s2, 2s2, 2p6 as an ion, having 8 valence electrons. So what's interesting is that these electron configuration for ions can be very similar for multiple atoms. Okay, and then we've got fluorine. So what does fluorine do? Fluorine is going to gain 1 electron. Right now, as a neutral atom, it ends in 2p5. So we've got 1s2, 2s2. When we add an electron, it becomes 2p6. This is interesting. 8 valence electrons, but right now, the oxygen ion, aluminum ion, and fluorine ion all look the same, okay? I call this noble gas envy because what is the actual configuration if it's 1s2, 2s2, 2p6? Okay, that would be neon. So what's happening for these ions is when they gain or they lose electrons, they're going to look like noble gases. And the reason for that is because noble gases are very stable. And that's why ions are gaining or losing their electrons to become stable like these noble gases. All right, try the last 2 on your own and check the key online. Okay, so the last thing I need to teach you in this video is how to draw the transfer of those electrons to form a compound. So it says ionic compounds form when a metal loses electrons to a nonmetal and the resulting oppositely charged ions attract. With your teacher's assistance, make electron dot diagrams for the following pairs of elements showing how electrons transfer to form the compound. Then write the name and formula for each compound. So we're putting a bunch of skills together. You really do need to be able to do this. So let's look at calcium, for example. After looking at your periodic table, you can see that calcium should have 2 valence electrons. Okay, and fluorine, on the other hand, is going to have 7. So what's going to happen here is that calcium is going to give away its 2 electrons and fluorine is going to gain 1. So I want to show that happening. Here's my calcium and here is my fluorine. Because remember, when they are happy, they have 8 electrons. So calcium gives away 1 electron to fluorine. Well, calcium's still not happy though. It has that extra electron. So what happens? Another fluorine is there to pick that up. So calcium donates 1 electron to one fluorine and its other electron to a different fluorine. That's why the compound for calcium fluoride is CaF2 because of this bonding formation. Okay, and we call this an ionic bond. So it's CaF2, known as calcium fluoride. Okay, let's look at the next one. Sodium and nitrogen. So sodium is Na, it has 1 valence electron. Nitrogen is just N, and it has 5 valence electrons. So again, sodium, because it's the metal, is going to give away its electrons. Nitrogen, as the non-metal, is going to gain electrons. So we're going to put nitrogen in the middle here. If I have 1 sodium, this electron from sodium can pair with that nitrogen. Well, nitrogen's not happy. It doesn't have 8 yet. It now has 1, 2, 3, 4, 5, 6. It needs 2 more. So there's another sodium with another electron to give away. Well, it still needs 1 more. So there's another sodium with another electron to give its electron away. That's why the compound between sodium and nitrogen is Na3N. 3 sodiums for every 1 nitrogen. This is known as sodium nitride. Go ahead and pause the video and try number 3 on your own. Okay, welcome back. Hopefully you had success with number 3. Here's the answer for number 3. So the dot structures for aluminum, it has 3 valence electrons. Oxygen has 6 valence electrons. Aluminum, as a metal, is going to give away its electrons to oxygen. So this one's a little bit messy if you look at my compound formation. But you could also do a little cheat and crisscross your oxidation numbers to know aluminum as +3, oxygen -2. So that they're going to form in a ratio of 2 aluminums for every 3 oxygens. And this is known as aluminum oxide. I hope you found this tutorial to be helpful. For more help, go to our website and look at the key online. Have a good night.